Now let's see the statement, the basic statement of structure of Matlab. There are virtually two kinds of structure of statement. The first is direct assignment. In C language, you may know this kind of command: A equals to 5, or B equals A squared, C equals A plus B, something like this. These are called direct assignment. You can use the expression on the right-hand side and calculate it, and then return the result back to the variable in the left-hand side. So it is a direct assignment type of command. And if you are trying to use this kind of command, A plus B, you get the answer like this: A and S equals to 30, where A and S stand for answer. If you do not have a left-hand side variable, then you will save the result as to answer A and S variable. So these are the basic statements of Matlab. They are called basic structure, the direct assignment. Now we can consider something more complicated. How to express a matrix. If you have a matrix like this, what you need to do is to give a command like this. Well, this part is the prompt of Matlab. So you can give a command like this. A equals bracket for the whole matrix, and then for the first line, we get all the elements separated by commas or space. They are the same. And then we use a semicolon to say that we want to start a new line and a new line. So we can express the three lines and express the matrix into Matlab environment. Here I use the commas and the spaces. They are exactly the same. You use whatever you like. So this is a matrix. So in this way, you can enter a matrix into Matlab. Once you have a matrix, you can analyze the matrix. For instance, as I talked earlier, you can use this command to find the determinant of this matrix. And you can get that easily. And also, you can get the inverse of matrix like this. So if you use this command, you can get an inverse like this. Or you can use EIG command to find eigenvalues of the matrix. So now the question is, you have already found the inverse. Whether the inverse is accurate enough, we have to check them. So A times B, it should be an identity matrix. So we can extract the identity matrix from it. And we will see that quite close. The error is very, very small, to 10 to the minus 14th degree. So the error is quite small. We normally can accept this kind of result in engineering view. So if you are not happy with the result, you can also convert using SYM command. Convert A into a symbolic matrix, then take the inverse. Then you can get exact results like this. And I shall explain the differences between the two results. This result, you say, they are expressed by rational numbers. And the other one is by double precision numbers. If you express this one by double precision, it will leave you 0.111 and you have 15 ones. The rest of the results will be truncated. So you can only reserve the first 15 bits. These are the numerical results. However, in symbolic results, we retain all the digits. We use the fraction number for the whole thing. So in this case, if we multiply A and B together, we will see that It is an identity matrix, so this is the exact result. So there are some different ways to express, or different data types to express matrices, and they are of different use. If you are trying to use symbolic method, you have to convert it to symbolic matrices. So in this way, you can easily represent a matrix in Matlab, and then you can use it to solve certain problems. I gave the similar command like this, and you can see the difference between the two instructions. There is a semicolon at the end of the sentence, which means the matrix will not be displayed. And this one, if there isn't a semicolon, once you execute the command, the result will be displayed. But if you use a semicolon, the result will not be displayed. So you can, in your program, you can use semicolon to suffice the display for the intermediate results. Let's see the third statement. It is a bit complicated. It is something like this. Here there is an A matrix. And this is the A matrix. Let's consider this part first. There is a semicolon means to change another row. And then 1, 2, and 3. So this is the left-hand side of this command. And this part, if you recognize as a row column, the column vector. 1, 2, 3, 4. So you can get a 4 by 4 matrix. Rather than, you can get a 4 by 4 matrix. So the dimensions of a matrix can be dynamically assigned, allocated. If you are using a C language, it is very complicated to do it in this way. In C, you have to predefine the size of the matrix, and if you declare it dynamically, you have to read it first and then relocate it again. It is quite complicated. But in Matlab, you do not have to do so. Just follow the Matlab syntax. You can get the result you expect. So in this case, you can easily express a matrix or even extend a matrix. And let's say more about a Matlab matrix. If A is an n by m matrix, so the subscript in the matrix will be 1 to n and 1 to n. And in C, you know, there should be 0 to n minus 1, 0 to n minus 1. They are different, but in Matlab, we have to remember the subscript should be from 1 to n. And also, if we want to find a certain element in the A matrix, for instance, we have find the element 2, 3, which means the second row, the third column, we can extract it directly like this. And we can use this kind of command to, this one, to extract the third column of the matrix. We can do this easily. Now let's consider what will this happen. We know A is a 4 by 4 matrix. Is this one useful? Is this one valid? We can try it. A is a 4 by 4 matrix, and we assign the element in the